Hello, we are very happy to have with us Professor Anand Subramaniam. He is the head of Department of Ocean Engineering here at IIT Madras. He has extensive experience in this field. He has been in this area for over 35 years now. So a lot of industry collaborations, lot of projects, lot of research projects, which may be extensions of concepts that were dealt with through industry collaborations. A lot of extensive visits and collaborations with international universities and so on. So he has a very rich experience in research, in dealing with students, in dealing with working with industries. Shaping students' lives as they go about through their master's degrees, PhD degrees, and so on. And so it is really a pleasure and privilege that he is able to join us today. His own areas of research are computer-aided design and application of CFD to floating structures, including ships and other floating bodies. So it's a pleasure to have you with us.
Thank you.
So I just wanted to start with this idea that in almost any field of engineering, there are certain areas that have been what we would consider as traditional areas of research, which have been around for a long time. Of course, even in these areas, there are newer concepts that people look at, but there are some areas that we would call as traditional areas of research. So in ocean engineering, what would constitute such areas?
To start with, I should say that ocean engineering is not a basic discipline by itself. It's an area that has emerged as a discipline consequent to the oil crisis in the 70s. Otherwise, ocean engineering would cover the major subset of ships, naval architecture in all its variants. So, offshore structures were then designed to be operated in the challenging environments of the oceans, and then of course there were support vessels. And then of course ships cannot just go and operate in the deep sea, they have to come to the harbor. So a whole lot of disciplines have been encompassed in what we now call ocean engineering. So there is the traditional design and analysis of ships and structures, their interaction with the waves, their propulsion systems, their navigation systems, the maneuvering, the seakeeping. Now from there, the offshore structures, which are huge man-made structures but not necessarily powered by an engine. They will have their own complexities of being floating bodies or compliant bodies or tethered to the ocean bed or articulated in some form. Then you have the coastal structures, ports, harbors, coastal breakwaters. So all these have now come under the umbrella of ocean engineering. And of course, I will be missing out because our department has now forayed into what we call petroleum engineering. Although strictly you can de-link petroleum engineering from ocean engineering, but that's what ocean engineering is. So coming to the traditional areas of research, we can take up the challenges of all associated ship hydrodynamic problems in designing ships, in understanding the structures of ships, in the way the wind and the waves interact with the ship and therefore give rise to stresses, give rise to comfort or discomfort in terms of large motions, the dynamic effects that occur. So these are the traditional areas of research where you use modern tools such as, of course, finite element analysis, computational fluid dynamics, and these help you to therefore understand better and understand more precisely problems which were thought to be not solvable a few decades ago. So these are the traditional areas of research. Now when we come to the offshore structures, etc., there are long term problems such as fatigue, the failure of certain kinds of joints, and the challenges of handling this in the hostile environment in the oceans. So you inevitably come to interdisciplinary areas, even in this already multidisciplinary area of ocean engineering, that would be in terms of control systems, etc. So these are the new areas of research where it is neither a control systems expert such as from, let's say, the basic field of electrical engineering, nor is it the naval architect. They have to work together and they have to understand these. So, these are the new areas of research. Like this, we could extend to the area of petroleum engineering, because the challenges of exploring below the ocean bed for oil and having to monitor the process of drilling, these involve lot of new challenging areas. Again, the quest for energy from the oceans, we have the new areas, how to tap energy from the waves. So, we have a whole lot of devices. Some of them have been demonstrated to be technically feasible, although still not commercially viable. So, we have structures called ocean oscillating water column, backward bent ducted buoy, hydro turbines wherever there is current available, ocean thermal energy conversion. So, all these have given rise to new areas of research.
Okay. So, a lot of traditional areas and several significant new areas that.
Yes.
So, of course, I think maybe more so than any other discipline, I think clearly in ocean engineering there is a direct link with applications that are visible to the general public.
Very much.
In this context, of course, when we talk of research, we tend to talk of the latest, the cutting edge, and something that maybe has a tendency for us to be associated with an academic setting. So, in this context, what aspects of research that go on in ocean engineering are of maybe more immediate interest to the industry?
Yeah, that's an interesting question, because traditionally industry looks forward to fast, robust, tested solutions rather than deep involved research which demands handling of it by vertical experts. And this is something that has been catered to the industry, that we traditionally had the problem of analysis and design, because again, if I take the example of a ship, it's the largest man-made mobile object. The challenges of making this structure safe and seaworthy means you have to analyze it using today what we have trusted tools like finite element methods for the structural analysis, computational fluid dynamics for analyzing the forces that are coming out of it, and trying to address the problem of safety and comfort also, because you have a lot of dynamic effects occurring, such as what we call shipping green water, reducing the possibility of water coming on board the deck, or trying to minimize the motions. So, these are solutions which the industry looks forward to. I could add, let us say for the example, the Indian Navy too, that we do offer solutions in these areas by analyzing and experimenting with the kind of floating body that they have in their hands. To that extent, the Department of Ocean Engineering is well endowed with a very rare combination of facilities which cannot be thought of under the university umbrella. So, to name them, we have the towing tank, we have the weigh basin, we have the flumes, we have the best of instrumentation, automation, that we are able to give solutions to the industry by giving them immediate answers to specific problems. But long term, research continues, because as I said earlier, the industry cannot wait for a expert solution that requires a lot of expertise in handling. Again, from the industry problems where we get live data and with regard to the ships or with regard to whatever the floating structure, we take it up further by way of analysis, and here comes the interface of academic research, industrial consulting, and providing solutions. That is where we have an interesting combination, that we are able to use these sources that we get from the industry and try to match it to international levels of understanding. It's not just offering the solution, sometimes it is understanding the physics of the problem. It may not be that we really form a solution, but we even sometimes know that a certain approach cannot be had, and I would say that all these help in contributing towards the research that the department undertakes.
Okay, great. I when I look at ocean engineering and say compare it with other disciplines that are around, including say mechanical engineering, chemical engineering, a lot of other disciplines, one of the things I think where the ocean engineering department stands out or stands apart is the fact that maybe there are not enough undergraduate programs around in the country or maybe even internationally which are focused on in this area. So by the same token, so when MS and PhD students come into your department, maybe they are not, I'm curious to know to what degree you feel they are adequately prepared for handling what research is specifically in your field. And if so, or in that context, are there specific difficulties that they face as they come in, challenges that they face, and if so, how do you go about addressing it?
Yeah, I think you have pointed out to a relevant issue there, because as I have said, ocean engineering is not a basic discipline by itself, and candidates that we get for our master's and PhD program are drawn from many disciplines, typically mechanical engineering, civil engineering, some from naval architecture, many from aerospace, and of course because we have the petroleum engineering, there are candidates coming from science backgrounds, oceanographic backgrounds, geophysics and so on. But let me dwell on the main part of ocean engineering. There is a learning curve that these students have to understand what the department is about, what are the main courses. We do have a challenge because with a relatively small number of faculty, being able to satisfy the requirements that these students need to go through, we do find that unless they have gone in a little in depth into some of the fundamental aspects such as hydrodynamic structures and of course whatever else they want to take up in their research areas, there is a little bit of I would say a limitation that they could do better if they were geared for that. I must also say that unfortunately research is being made a rat race, that there is a tendency to go for numbers. Maybe it is the numbers of degrees produced, maybe it is the numbers of visible outputs produced, and that in my personal opinion is counterproductive. If we could address that problem and allow people to learn and experiment and then go about, I would say the quality of research would go many notches above.
In fact, it's in that context, I was curious since you have had so much experience working with industry and research institutions internationally as well as in India and so on. In your view, in fact, exactly as you pointed out, there are certain metrics that people use, and sometimes those are even misused. In your view, what is a good way to look at progress in research from a student perspective, or as as you interact with the student, how would you feel? When do you feel that the student is actually making progress in a general sense with respect to research?
Yeah. I think the first step would be that the student should not be straight-jacketed that from day one a problem is presented and he is asked to work on that. We have to allow the time for a little bit of learning. I know that students will work, or for that matter anybody will work only under pressure. So the pressure has to be applied on them. But this pressure of looking for numbers, if we could take it out, would help them to settle down. The system expects the numbers, therefore they are busy preparing numbers. So I think we should de-link this to some extent without reducing the pressure on them, which means that in a first semester when they typically are busy with their courses, the mandatory courses to be taken, we should allow them to interact with others in their peer group, meaning other researchers, learn the basic tools, because I personally believe that research, whether it is at the MS or PhD level, is reaching the peak of the pyramid. So there is a base, irrespective of what you are doing. Students have to be mandatorily exposed to that and have to get the confidence of that and finally learn to stand on their feet. If this model could be addressed, I don't think this is idealistic. I have been trying to apply this to my own group, and I would say in all humility that we have been successful. Maybe the time doesn't meet the stiff deadlines, we don't get a PhD in 3 years or something like that, but I feel this is a much more wholesome way of approaching research, and more important is students who come through such a process are easily absorbed in jobs, which is a very satisfying end result of all the work.
In fact, in this process by which this student settles in and grows in the research area, in the research setting, I think there is a lot of importance to the extent to which the students interact with their peer, other students who are present, and also with the faculty that they work with, their guide, and so on. It may be a bit of a mundane question, but in your view, what do you see as, how often should students be meeting their guides? Because it's very different from a course-based kind of learning. There's a lot of, influence and importance to this interaction that makes a difference in how they grow. So, what do you think are, good frequencies with which people should be meeting the guides, and how they should be going about it?
Yeah, that's again a very interesting question, because whenever I have addressed the students in the research methodology course, I have tried to put this question as a starter for the course. How many times do you think you should meet the guide? So, I get lots of formula on that, and of course, many students obediently feel they should meet their guides regularly. I am against that. I would say there should be a contact with the guide, yes, and the real smart student is one who will get the cues through many casual meetings and also with the meetings of other students. So, in an ideal sense, if you want to put a number, maybe once a week is fine, but more important is the student is able to stand on his feet, put in his efforts, because I have always seen that there are so many students who you may be seeing around, but they come back with results. That is a very important thing, and they don't get the results straight. It's not that it's an easy problem, but they have learned to reach out to different sources, put their effort, done their design, done their fabrication, even gone to the market and got the things, fabricated it. Again, I would say, maybe I am just putting it in my experience, that I have a group of about 30-40, and we have everybody for everything. So, whether it is the software and induction of the newcomers into the learning process for different softwares, or whether it is the fabrication, or whether it is experimentation. So, I see a harmonious group. Therefore, I would say that building a group is very important to help succeed in research, and learning from each other rather than just from the guide. So, I don't think that it is important to meet the guide on a very frequent basis. If they have to meet, most welcome. I do not think that that is a formula to success.
Okay, great. I think that's a very valuable insight into what should be going on, and or at least how the student should approach it in their mindset. Exactly. So, you were speaking about the successful students who complete all their activities here successfully and so on. Now, when we look at MS and PhD research type of students, there is always this feeling, not just in ocean engineering, across all disciplines, that when you do an MS or a PhD, you are an expert in a sort of a narrow area, as opposed to a generalist which is what we would associate with a bachelor's degree. Of course, being an expert is a good thing, but at the same time, that probably narrows down the kinds of positions that they can get into, the jobs that they can get, and so on. So, in your experience, what sort of positions do MS and PhD students completing degrees in ocean engineering, what sort of positions do they go to or they get?
Yeah, I do believe that acquiring a higher degree in the environment of IIT does not mean achieving proficiency in a particular vertical area alone. That is important, but more important is the problem solving capability, the ability to look at something independently and in depth, the ability to get a team together and work. To me, these are the strengths which give them the job opportunities. Again, I would say I have been very lucky that all my scholars at the time of finishing have been already placed in a job. Of course, there are disadvantages that the student has no time to prepare the visible research outputs. This is only a hassle. Otherwise, I would say that they have been by and large placed, and I would say that the reason for that is because they have broad based themselves because you do not know which particular opening you are going to get. So essentially you have to take your research here as a learning experience, the ability to solve problems, and with this they are able to adapt. Typically my students have been going to the design organizations, maybe shipyards, maybe offshore industry. They have been able to join the computational fluid dynamics application software development companies such as CD, Adapco and so many others, Eaton and so on. They are there in many industries where they get compartmentalized and are looking at part of a CFD solution there, either formulating or developers or testing, etc. But by and large, I would say whatever they have done, there is a level of confidence which they exude, and that seems to help. To me, that is a very important thing, because if you are lucky, you manage to work in the same vertical area that you chose for a PhD. But most of the time you have to be open enough, because maybe some other day you will come back to the area, or maybe destiny will take you to some other area. So I think we all have to take it easy, enjoy the research, do what you are doing, don't lose sight of realities, be able to project that you are versatile. To me, this is most important.
Oh, great. Okay, I think maybe you have already sort of addressed what I wanted to ask you next, but in any case, I just wanted to know, are there any specific words of advice that you have for students who are aspiring to join an MS and PhD program in ocean engineering?
Yeah, for students who are aspiring to join MS and PhD, first they have to feel convinced that they are not venturing into some unknown area. They have to feel comfortable. I do feel that the branch is so broad-based and so multidisciplinary and interdisciplinary. The adaptability with which they can go and work in so many wide areas of specialities, that is one thing. The second thing is people need to learn to share and exchange knowledge. It would be very wrong to think that you are working in a narrow area, you would work rather individually, or you would rather work in small groups or even as individual, because to me these are much more important in achieving success in a future career. The other thing is, don't forget to be happy, because if you are not happy, whatever you do, you cannot get the best of things. Again, I say this from experience, because if a student or a teacher or whoever is not going to enjoy what he or she does every day, there is no motive, because finally there is a life philosophy that the objective is to be happy every day.
Oh, great.
And follow that.
Very nice words to conclude this discussion with. I think so. It talks about both professional growth and personal growth and philosophical
connected.
Growth. Great. So thank you, Professor Anand Subramaniam, for joining us. It's a pleasure that we could have you.
It is my good fortune that you wanted me to say a few things.
Oh, it's a pleasure.
I do hope this will benefit researchers, new students who want to look into IIT and make the best out of their career.
Thank you so much.
Yeah.
Thank you.